Okay, guys, we are now at our lesson 12, which involves database backup, restoration, and maintenance. Now, for database backup, we will concentrate first on the SQL Server database backup. SQL Server backups in itself is a vast subject, so vast that there are multiple books written about it. In this lesson, however, we are going to focus on the types of backups that are available to us and understand how to pick what we need and what aspects we base that decision on. This understanding would in turn help us decide our backup and restore strategy. The following are the most common types of backups available in SQL Server. We have the full, differential, transaction log, and the tail log backup. There are other backup types available as well, which are the copy only, the file backups, and the partial backups. When we say full backup, a full backup backs up everything. It is the foundation of any kind of backup. This is a complete copy which stores all the objects of the database, including tables, procedure, functions, views, index, triggers, etc., etc. Having a full backup, we will be able to easily restore a database in exactly the same form as it was at the time of the backup. A full backup creates a complete backup of the database as well as part of the transaction log. Now, for anyone who is not familiar with the transaction log, it is where all the transactions are recorded before they are updated to our database or to our actual database. It's like a logbook. So the database can be recovered. This allows for the simplest form of database restoration since all of the contents are contained in one single backup. A full backup must be done at least once before any of the other types of backups can be run. This is a foundation for every other kind of backup. How do we create a full database backup using TSQL or the SQL for SQL Server? The backup database is the command used to create a full database backup. It requires at least two parameters, the database name and the backup device. This is an example. So backup database, enter the name of your database and then to disk, followed by the path where you will place your database. We also have other parameters here that will be discussed after we have discussed the types of database backup. So these parameters will be explained later on. So for now, kindly focus on the first two parameters that we have, the command backup database and the to disk command. For this example, I have created this particular command wherein we are going to back up our test database to the folder or to the directory D under the folder backup with the file name testful.bak. Now, BAK is the default file name for our SQL Server backup. Okay, so in this instance, we have provided the parameters for the media name and the name. So once you execute this one, okay, so first I will delete the files, okay, and then I will execute this one. So take note, we are under the master database, meaning this is the main database file wherein we are going to execute our code. We do not need to select a particular database in our SQL Server Management Studio. So we are under the default master database, and then we are going to execute full. backup database command. So upon executing, notice that we have under the messages, we have backup our database file as well as the transaction log. Okay. So it will be stored in our path, okay, database path. Now, upon creating your database backup, you could actually restore it using command, okay, using SQL command, or we could just use the GUI. So we have right click your database and then we have an option here to restore either database or file group. So we are going to, for example, we're going to restore the database. And then usually automatically it will find the latest database backup that you have created. So for this one, for example, we have created this one earlier. So notice the name is visible and then all the other details, the date and time that we have started the backup operation. We can even verify our data. So you could do that, or you could select the location wherein we have created our database file. So let's select the folder and then the file. Okay. And then it will display the information with regards to our database backup. The next command is a full database backup to multiple files. Sometimes in some instances, we're limited to the amount of space we have. What if we wanted to back up an entire database that is huge? Or what if we have to copy the backup files over the network? It might be a good idea in this case to split the backup into smaller chunks, each being a separate file. So in this example, we have a database backup which is split into four different files. Okay, so we have this example. Okay, and then the file can be found here. So notice the file size for each file is smaller because we have separated it into four. Unlike the full database backup, which is larger, this one requires all of your database sets to be complete. Otherwise, the restoration process will not be successful. So let us try to check what will happen if we are going to use the multiple database file. So let's select all the four. Okay. But what will happen if I will only select one? Okay. Notice backup media set is not complete, missing family sequence number, meaning it has or you have to include all the other backup files also. We also have here an option to create a mirror copy of the backup file. So when we say mirror copy, it is basically the same backup file but in a different location. Okay. So in this example, we use the command. We use the option mirror to disk. Okay. In this example, we have here a backup and then the mirror of the backup. You could place, of course, the mirror should be placed in a different. directory, different physical media, okay, in order for this particular backup to be more secure. So unfortunately, we are using SQL Express. So this option is not available for SQL Express, but for the standard and other versions of SQL, the mirror option is available. And then we also have here sample that we could mirror up to 3 copies. Okay, next are differential backup. Differential backup is the superset of the last full backup and contains all the changes that has been made since the last full backup. So if there are very few transactions that have happened recently, a differential backup might be small in size. But if you have made a large number of transactions, differential backup could be very large in size. The differential backup doesn't back up everything. The backup usually runs quicker than a full backup. It captures the state of the change extent at the time that backup was created. If you create a series of differential backup, a frequently updated database is likely to contain different data in each differential. A differential backup increases in size. Restoring a differential backup can significantly increase the time that is required to restore a database. Therefore, it is recommended to take a new full backup at set interval to establish a new differential base for the data. Differential backup can save storage space and the time it takes for a backup. However, as data changes over time, the differential backup also increases in size. The longer the age of a differential backup and the larger the size, and at some point in time, it may reach the size of the full backup. A large differential backup loses the advantage of a faster and smaller backup as it requires the full backup to be restored before restoring the recent differential backup. Typically, we would restore the most recent full backup followed by the most recent differential backup that is based on that full backup. In short, differential backups cannot stand alone. It requires a full backup. But the good thing is that differential backup only backs up all the changes since the last full backup. So if your database is frequently updated, could actually be faster than doing a full database backup because not all the data will be required to be backed up. How to create a differential database backup? The backup database command is used with the differential clause to create the differential database backup. It requires three parameters: the database name, the backup device, and the differential clause. In this example, we notice that it uses the with differential um, keyword, okay, aside from the backup database and the destination file. Okay. So in this one, we will create a differential backup using our test database. Okay. So the file now here. So notice this is the full backup and this is the differential backup. So it's quite small as compared to the full backup because we have not made any recent changes to our database. Let us check if what will happen if we try to restore. So notice in our restoration, it also now shows aside from the full backup, the differential backup. Okay. Let me show you what will happen if we actually execute the backup. So let's try to click OK. You notice once it has been restored, the window will close. Okay. Transaction log backup. The log backup, as the name implies, backs up all the transaction log. It is possible only with the full or bulk log recovery model. A transaction log file stores a series of the logs that provide the history of every modification of the data in the database. Contains all records that have not been included in the last transaction log backup. So take note, it is only possible with the full or bulk log recovery model. The default recovery model that we have right now is only called a simple recovery model. So when we try to actually run a backup log, it will encounter an error. Okay, because we are using only a simple backup log. Okay, so the command for the backup log or the backup of transactional log is backup log, then database name, then path, okay, and then other parameters. As I have said, when we try to execute this one, this will not successfully execute because the recovery model that we are using is simple. So what we could try to do is alter the database and change the recovery model that we are using. Okay. Now, as you have noticed earlier, we have encountered an error when we try to create a transactional log because, as I have said, it only supports uh, a different recovery model aside from the simple recovery model. Now, if you want our changeable our database to make use of a full recovery model, we could try to execute this code. Okay, so we are using master database, and then after that, we alter our database to use the recovery model full or the full recovery model. After doing this one, your backup log will not work yet because what will happen is that because you are changing your recovery model, you will also need to change your database backup. So first, what you do is to back up your database again with a full backup. And then after doing that, you can now try to run your backup log. Okay, it's that process. Tail log backup. In the event of failure, when you need your database to get back up and running, the database is operating in full or bulk log recovery model. It's always easy to start the recovery operation and start the storing the backup. But before that, the first action to be taken after the failure is what is called as a tail log backup of the live transaction log. This is an immediate step that we need to take before we start the restoration. This process is called tail log backup restoration. So first, we use the master and then we create a tail log backup. So backup log, name of our database, and then to disk, and then with continue after error. It will force the SQL Server to store the log file even though it's generating an error. So let us try if this one will work. Okay, it worked properly. Take note also that you need to have a recovery model that is not full or that is not simple. You need to have at least full or other recovery model for this one to work. Otherwise, if your recovery model is simple, this will also not work properly. Copy only backup is a special type of full backup which is independent of the conventional sequence of backup. The difference between a copy only and a full backup is that a copy only backup doesn't become a base for the next differential backup. A full backup works on all database recovery model. Copy only backup, on the other hand, is only applicable to a full or bulk log recovery model. The restoration of a copy-only backup is no different than a normal restoration process. So the syntax is okay, backup database, database name, and then the our path, and then we have with copy only parameter. We also have the backup log, and then the with copy only parameter. So let us try to run this one on our test database. Okay. This is a copy only backup. If you are also creating a backup using the GUI, what you could do is to right click your database and then go to task, click backup, and then you could perform a type of backup that you want. Okay, so you can select the database, you can select the type of backup, then you could perform here copy only backup if you want to. So the GUI, everything is also available there, including all the other options. I'm just showing you the code so that you know how the inner workings of the backup is happening. Partial backup. Partial backup are one of the least used backup methods. All database recovery models support partial backup. They are mostly used in the simple recovery model in order to improve flexibility when backing up large databases that contain read-only file group. The read-write file groups option is used with the backup database option. It processes the backup of read-write file groups. So in this example, we have SQL Shack partial backup created with the primary and secondary file group. Okay. So it meaning to say it doesn't only have a primary file group, it also has a secondary file group. So what happens here is that we are creating a partial backup of the primary as well as the secondary file group, as well as the log. So we have here a sample code on changing the our database from full to simple. Earlier, we have changed it from the default of simple to full. Now, you could also ticket this one in order for you to change it back to simple. Now, we do not have or we are not using a secondary file group. So, this commands will not work. But let's see if we could try to add a file group. So notice I'm doing this one via the GUI, secondary file group. And now I have two file group. Let's just try to execute our partial backup. So create database, test2 on primary. This is our um, backup database name. So notice the file extension is same as that of an actual database, not BAK but MDF file. Then we have the secondary file group on test backup 2. And then we have the log. Let's try to execute. Database test 2 already exists. So let's try test 3. Okay, so let's try to check. So as you see here, we have test backup 1. test backup 2, and test backup log. So let's try to return our database back into a simple recovery model and then change our secondary file group to read only. So our second one did not execute successfully because it doesn't contain any file, but our database test has now been converted back into simple recovery model. Uh, okay, the recovery model is now back to simple. Okay. File and file group backups. The topic is relevant for SQL Server database that contain multiple files of file groups. File backup or read-only file groups can be combined with partial backup. Partial backup includes all the read-write file groups and optionally one or more read-only file groups. We'll create a database with multiple files and file groups. So let's try to create a database. Okay. So we will use the default directory that we have, which is the backup. So we will be creating uh, primary file backup 1, secondary file backup 2, and then the log file for our database. Let's try to run. Okay. So we have now created our database file located here. Okay. Primary, secondary, and our log file. So if we are to create file level file level backup, let's try. So primary file group cannot be backed as a file because the database using the simple recovery model. So it needs to use a different recovery model. So I'll try to attach our database. Okay. So we're encountering an error, unfortunately, so we cannot run our file backup command. So file backup command can only work for other recovery model aside from simple. Other unless you are using full or bulk log. So we also have the backup for our file groups here. So let's try if this one will work. But I doubt this will execute because I think it will also use a different recovery model. Okay, so yes, need to have a different recovery model. So next is the options that we have. So for the options, we have compression, which enables backup compression. Compression is how the data, the output file is created. So usually we need to set a compression, especially if the data base is very large. We also have encryption to secure the backup files so that it will not be used by anyone. We also have the media options. We have the format. So use to specify whether to overwrite the media header information. The format clause will create a new media backup set or new information when we try to restore our backup, whereas a no format option preserves all the information. We also have the init, the name, skip, no rewind, no unload, and stat. So useful to get the status of the backup operation at regular stages of its progress. Planning backup is relatively simpler for smaller databases, but as they grow in size, the management of backup can quickly become a complex and tedious job. With planning and defining the right backup and restore recovery strategy, we would place ourselves in a good position against any sort of failure. A full backup is always easier to restore, but it is resource intensive operation and takes longer to complete. So we've covered different backup types with examples in this lesson, giving you an idea of the available backup types and the basic purpose of each backup type. For example, an index rebuild operation, consider the time required and make sure it only occurs right before a full backup so that all of those changes don't need to be rolled up into differential backup. To speed up a backup operation, consider moving historical data to archive file group and split the read-write data and read-only data into separate file groups, giving you the flexibility to back up only the read-write file groups and the respective files. Using the available backup compression options, we can reduce the amount of data that needs to be backed up, removing the extra burden on storage and transfer resources. I have created here a sample stored procedure that will create a full differential and log backup file. Okay, so all you need to do is copy this one. What it does is it will ask for the name of the database and the backup that you want. And then for the default file name, it makes use of the date today. And then it will append the full differential or log on the file name, depending on the data that you are or the database backup that you are requiring. So it uses string. So notice we are using string command. And then in order for us to execute the string, we use another stored procedure called sp execute SQL, which execute string command into our SQL command. Okay. So this is our code. So I have used our folder that we have used earlier. So let's try to make a full backup. The full backup is okay here. Then we create a differential. Okay, this is the differential. And then we try to make use of log. It's not allowed because database simple. So what we could do is change it to full. And then, as I have said, if you try to run the log, it will counter an error because you are required to make a full database backup first and then the log. Okay. Transaction recovery. Database transaction recovery uses data in the transaction log to recover a database from an inconsistent state to a consistent state. There are four important concepts. The write ahead log protocol ensures the transaction logs are always written before any data are actually updated, ensuring that in case of a failure, the database can later be recovered to a consistent state using the data in the transaction log. Redundant transaction logs ensure that a physical disk failure will not impair the database management system's ability to recover data. We also have database buffers, which are temporary storage areas in primary memory used to speed up this operation. Database checkpoints are operations in which the database management system writes all of its updated buffers to disk. A checkpoint operation is also registered in the transaction log. The database recovery process involves bringing the database to a consistent state after a failure. It generally makes use of deferred write and write through techniques. When the recovery procedure uses a deferred write technique or deferred update, transaction operations are not immediately updated to the physical database. Instead, only the transaction log is updated. The physical database is updated only after the transaction reaches its commit point using information from the transaction log. If the transaction aborts before it reaches its commit point, no changes are made or no rollback or undo. When the recovery procedures use a write-through technique or an immediate update, the database is immediately updated by the transaction operator operation during the transaction's execution, even before the transaction reaches its commit point. If the transaction aborts before it reaches its commit block, a rollback or undo operation needs to be done to restore the database to a consistent state. Okay, so after using SQL Server to backup and restore our database, how about using MySQL in order, or what can we use in MySQL in order for us to back up our database and restore the database? What we use is the MySQL dump utility. So it's a separate program found under your MySQL installation. So let me show you. So this is an example of a MySQL installation for SAMP. So notice there are different programs. So one of the programs that we use is called the MySQL dump command or program, which contains the command for dumping or backing up our MySQL data. We could also use third-party vendors as backup solutions, but MySQL generally uses the MySQL dump utility. Okay? So we can generate the backup of MySQL databases using any of the following methods. Number one, using the MySQL dump utility. Number two, incremental backup using the binary log, or generate backup using the replication of slaves. So in this lesson, we are going to focus on using MySQL dump. It is a command line utility used to generate the logical backup of a database. It produces SQL statement that can be used to recreate the database object and data. Can also be used to generate the output in XML, delimited text, or CSV format. The command is easy to use, but the only problem that occurs while restoring the database, as I mentioned, when we generate a backup of the MySQL database, it creates a backup file that contains SQL command that is necessary to rebuild or restore the database. Now, when we restore the database, the command executes all the SQL statement to create tables and insert the data. If you have a large database, then the restoration process takes a long time to complete. There are lots of options and features that can be used with MySQL dump. So the syntax for MySQL dump is first, okay, we need to open the location of your MySQL dump. So if you are using Windows, we are going to use command prompt under with administrative privileges in order for us to execute the command. And then under your command prompt, you need to open the directory where MySQL dump is located. So in my case, it's under drive D. Okay. Every time you execute a command, you call MySQL dump. These are the parameters that we are using. Dash U, which pertains for the username. Dash P for the password. And then we have the option, the database name or table name. You also have uh, less than or greater than symbol used to indicate if we are generating backup or restoring the database. The greater than symbol is used to signal backup, and the less than symbol is used to signal the restore operation. Then lastly is the SQL file name. In this example, if we want to create the backup of a single database file, what you could do is to call MySQL dump dash u and then provide the username dash p, okay, and then provide the database name. Use the less than symbol to indicate that we are backing up the data, and then provide the location where you will store your database file. So for this example, I will delete previous samples that I made. So make sure you are under the directory of the MySQL dump. Okay. Again, we have MySQL dump dash u, provide the username dash p, provide the database name, then the path and the file name wherein you will save your data. So we are going to use the greater than symbol to indicate that we are going to use the, yes, greater than symbol to indicate that we are backing up the data. Press enter, it will ask for your password, and then this is your full backup. If you are to open this one, notice it contains data to drop and recreate as well as insert the data found in your database. We can also use it to create backup of multiple databases. What you could do is to use the parameter dash databases followed by the different database name followed by the SQL file in which you will store them. Or if you want, you could actually um, back up all the database found in your MySQL server instance using the dash all databases option. So for example, we are going to back up all the database that we have. Dash all dash database databases. Enter and then I name all db full. Okay. Okay. So in our folder, this is all the database that we have, different tables and data. Okay. You could also back up just the database structure, meaning to say no data will be included. So in order to do that, we use the dash dash no dash data and then the database name. Okay, so let's try to do that. Dash dash no data dash dash no dash data and then database name. Okay, okay. So notice the file size is smaller because only the structure is created. How about for a specific table? So let's try to run that one. For example, I have students table. So the syntax is database name followed by the table name. Student and table student unknown database. Sorry, student. So database name space table name. Okay, so that again. Student. Okay, check. Okay. You see the code should only be table students. Okay. Then we could also create only the data. So using dash no create info dash dash no dash create dash info. Yes, data only. Okay. So it should only contain, if I'm not mistaken, insert statement. Okay. Notice only insert statement is found. So if you want to restore the database, okay, using the file that you have made, instead of using MySQL dump, you use MySQL. Okay, so I have here MySQL window. Okay. Sorry, we will not use the command line. We will use the same window. So instead of using MySQL dump, just change it to MySQL. Why? Because we also have here the MySQL program, which will support our restoration. So let's try to restore it. So I will use the file that we have created earlier. First, let's create a fresh database backup. Okay, we dump. Okay, and then next is change the symbol to less than to indicate that we are restoring, and then use MySQL program. Okay, there you have it. You have restored your database. So for example, we are going to drop our table X and Y and refresh. So let's try to restore it and see if the table will be restored. Okay, refresh. Okay, so there you have it. That is how you would restore using our MySQL code. So we have here different samples that you could try if you have a MySQL installation. Unfortunately, it will be hard to use Fiddle or our online editors because we need to provide a physical path for our database backup. Okay, so thank you guys and good day.